Hello everyone, good evening. My name is Nehel and welcome to another stream by OneClass. Today we'll be covering a few questions, a few math questions. These will be ranged from anywhere from the high school to university level questions. Just a little bit about myself. I am a University of Waterloo graduate. I graduated there in 2018. I went there to study mechanical engineering and I've been working for the past two and a half years after graduating as a project manager in the plastics industry. Next up for me is that I'll be doing my master's degree at U of T starting January, so I'm really looking forward to that. Okay, so without further delay, let's get into solving some math questions. Okay, so the question one for today is what is the domain and range of a function? So let's say we have any function y is equals to f of x, where f of x is any function dependent on the variable x. The domain is essentially, let me just write it down first. Domain. So there will be certain values of x where the function is defined and certain values of x for which the function is not defined. So the values of x where the function is defined would be the domain of the function. When I say defined, I mean that the the final value of the function is computable, and non-defined will be when it's not computable. So I'll give you an example in just a second, but let's just write down the definition. So the domain is uh, the range of values of x, or in any variable, in this case it's x, where the function is defined. Okay, so similarly, we also have the range of a function. Now, the range of a function is all the values the function can take. When I say function, it's actually all the values of y, in this case, which can take for all the corresponding values of x, which are part of the domain. So the definition of the range is all possible values of y, which are in the domain of the function. Of the function. Okay, let's look at one quick example. So if I had a function, let's say if I had a function y is equals to f of x minus something, let's say my function is y is equals to 1 of x minus 1. So now the range, or let's compute the domain first. The domain would be the all possible values that x can take where the function is defined. So the domain is all possible values of x. We know that this function would not be defined when we divide by 0. So this would not be defined. This is an undefined function, so we can't have this. So to be able to compute for that, we can set x minus 1 equal to 0. Therefore, x equal to 1. From this we can say at x is equals to 1, our function y is equals to 1 minus 1 over x minus 1 is not defined. Therefore, the range of the function will be all real values except the number 1 for this. So therefore, range is equals to x belonging to negative infinity to to 1 union 1 to infinity. The square brackets implies that the value 1 is not included. Therefore, we will not ever have the case where the function is not defined. Just for a quick example, if we had something of the sort y is equals to x square minus 1, in this case x cannot be equal to -1 as well as +1, so that would have a different range. Okay, so now for the same question, if I want to compute the domain, oops, I meant to say domain here. And then if I want to calculate the range, which is all possible values of y, what I can do is I can solve this equation for y. So we would have x minus 1 is equals to 1 over y. Therefore, x is equals to 1 over y plus 1. Now looking at this again, we know that we cannot have a case where y is equals to 0. Therefore, our function y cannot take the value of 0, which would mean that that's not part of the range of the function. So for this expression, y cannot be 0. Let me just write that down. So given x is equals to x, you can look at x as the domain, 1 over y plus 1. For y is equals to 0, we get 1 over y, we will get 1 over 0, which we cannot get, which means it's undefined. Therefore, the range of the function is essentially y belongs to -infinity, comma 0 union 0 to +infinity. Okay, so just to quickly recap, the domain is all the possible values of the variable, and the range is all the possible values of the function itself. And to be able to compute the domain and range, what we can do is we can try and identify places where the function will become indefined for x, and then to compute the range of the function, what we can do is we can solve for y, and then try and identify the places where y will cause the final resultant equation to be undefined. Okay, let's look at the solution. A possible value of x while the range possible value of y. Perfect. For the corresponding value of x, that's very important. For example, to find the domain of the function cannot be equal to 0 because it gets undefined. And then you substitute, so you would have all the values except 0. So that's correct. So this answer is correct. So question number 2. How would you write the expression 2 to the 1/6 in radical form? So radical form is the simplest square root type form. So the question asks 2 to the 1/6 to radical form. So if I were to quickly give you an example of what radical form is, if I was given 4 to the power of 1/2, I can simply say this is equal to 4 to the power of 1, and then the 2 comes out of the square root, which we all know is equal to 2. So similarly, you can see a pattern here. If we're given any number a to the power of b/c, the simplest way of writing it would be square root, c comes out, a stays in, to the power of b. Okay, so therefore for the number 2 to be 1 over 6, this would correspond to 2 stays in with the 1 and the 6 is outside of the square root. So we have to find the 6th root of 2 essentially. So we would obviously need a calculator for that, so we won't compute it, but this is the final radical form of this expression. So this is correct. Okay. Next up is question 3. So this is a conversion question. We are required to convert from meters to miles. Okay. So for question 3, how many meters is a mile? Or in fact the other way around. We are given 1 mile and we want to find out how many meters we get. So we need to convert from miles to meters. Okay. So to be able to do that, we need to know a few conversion factors. So I'm just going to list them down here for you, but it's easier if you remember them, or if you try and remember some correlations between a few of them at least, so you can convert from one to the other. So right off the back, what I will do is I will convert miles to feet. So 1 mile is equal to 5280 feet. Now I know to be able to get to feet, to be able to get to meters from feet, I need to go through inches, then centimeters, and then get to meters. So what I would say is 1 feet has 12 inches. Now to be able to get from inches to centimeters, I know the factor is 2.54. So 1 inch is equals to 2.54 centimeters. And then we know 100 centimeters equals to 1 meter. So therefore, the final formula for this would be, and I would write this in the fractional form with the units. So 1 mile, then we multiply it by 1 mile corresponds to 5280 feet. Then 1 feet corresponds to 12 inches. 1 inch corresponds to 2.54 centimeters, which then corresponds to, or 100 of those correspond to 1 meter. So when we compute all of this, we would get our final answer. So I'm just going to use a calculator to calculate this. So 5280 times 2.54 divided by 100. So the final answer should be 1609. Perfect. Okay. So this equation solves down to be 1609.34 meters. So again, just a quick recap. For these conversion types questions, it's easier if you do it in this factorial form, where you try and go step by step from one unit to the other, all the way till you get to the final unit. That way, you can visualize it better, and in your mind, you can see that this mile is getting cancelled with this mile. This feet is getting cancelled with this feet, inches with inches, and then centimeters with centimeters here. So at the end, you're left with just the units of meters, and then once you multiply all the numerical values, and you're left with 1 unit, that's your final unit and the final answer as well. So explanation: to determine how many meters are in a mile, we use the following conversion factors. So 1 mile is this many yards, and yards to feet, feet to inches, inches to centimeters, and then centimeters to meter. So that's perfect. So the solution is correct. Okay. Question number 3. How do you simplify complex fractions? So complex fractions are essentially when fractions have fractions inside themselves. Question 3. So generally you would be aware of a fraction such as a over b, or a fraction such as a mixed fraction, um, such as c times a over b. But then there are also complex fractions. Okay, so complex fractions are when you have two fractions divided by each other. So they would be of the form a over b divided by c over d. Okay, so you have two fractions divided by each other. So the way to simplify this is essentially you would be looking at so this is the numerator 1. So if you want to call it n1, n1 is the denominator 1, this is numerator 2, this is denominator 2. The way to look at it is that this number p is actually being multiplied to this number c, and this number d is actually being multiplied to the number a. Essentially, what that means is we have something of this sort going on. A over b is nothing but okay. And now, if you want to convert the opposite of multiple, you would say that's equal to a over b divided by 1 over c over d. So that's essentially how you convert. So since we were in this stage to begin with, to be able to convert to this stage, we would get a non-complex fraction. So therefore a over b divided by c over d is nothing but a times d over b times c. So you can just, as a note of reference, you can think of it as like the lowest terms comes to the bottom, and then the second terms go and goes with the third term. Okay, so here we've given an example as well. So if you're given two fractions, 1 over 2 and 3 over 4, actually maybe I should give an example as well just to clarify if there's any questions still. So if we're given a fraction, let's say 1 over 2 divided by 1 over 4. So as I said, this number and the third number comes together, and then this number and their top numbers comes together. So essentially what we have is 1 times 4 over 1 times 2, which is equals to 2, which makes sense because if you have a portion which is divided in 2 halves, and then you divide that portion further into 4 halves, you'll be left with 2. So that's correct. Similarly, what they have done is 1 over 2 over 3 over 4 is the same as 4 over 3 multiplied by 1 over 2, which is correct. The answer is correct. Okay, next up, question number 4. What is the binomial expansion of this given expression? So The financial, I think the easiest way to solve this question is to just remember the identity for this. So there are a few identities, and I'm going to just list out two for now. So identity number one is when we have x plus h whole square is equals to h square plus x square plus 2xh. And then for this question, we actually have this identity. So instead of a square, what if we have a cube? So there'll be x cube plus h cube plus 3x squared h plus 3h squared x. So we have both the expressions and their respective cubes plus 3 times the square of the first number multiplied by the second number plus 3 times square of the second number multiplied with the first number. So I think the easiest way to solve this question is to just recall the identity and use that for the solution of the question. So they have done that as well. That's perfect. Okay. So the solution is correct in this case. Okay. Let's go on to the next question, which will be question number 5. Okay, let's give this a second. It should load up any second now. Okay, so looks like we're back. Sorry for the minor interruption. It took a second for the question to load up, so we can continue with the next question. All right, so question 5 for today is, what is a cubic foot? So cubic foot is essentially a unit of volume. So essentially what we're talking about is an expression which is feet to the cube. So the easiest way to talk about this is if we have a one-dimensional or one-sided shape, one dimension is correct. We would have something of a line. If it goes to 2 dimensions, this would be, let's say, so in this case, the first dimension would be the length of the line, which would be represented in the units feet. Now, the second dimension would be the area of this triangle, let's say, which would be represented in the units feet squared. And then similarly, the third dimension would be if we go and we find the volume of any figure. So if we had, let's say, a cuboid, So the third dimension would be the volume of this, which would be, when we calculate this, the formula is essentially the sides multiplied by each other 3 times. So it's a times a times a, if a is the side of this cube, which we get to be a cube. Now, if a is in the units feet, we can see that the volume would have the final answer to be a cube, which is a numerical value, and then the units would be feet cube, because when we're multiplying them with each other, the feet unit also gets multiplied. Similarly, if we look at the area, we know the area is half into base into height. Therefore, these two would have the dimension of units in them. Therefore, we get the squared value as the final dimension. So cubic foot is essentially a dimension for the volume of a given shape. Okay. So one dimension is length, 2 dimensions is an area, and then 3 dimensions will be volume. Perfect. And then there are multiplication of the sides, so that's correct. So the solution okay. Okay, question number 6. What is a four-sided polygon? So a polygon in general is any shape which is created by connecting 3 or more straight lines. So the simplest polygon which we can have is actually a triangle. So 3-sided would be the least number of sides we would need in order to complete a closed shape. So 3-sided is a triangle. 4-sided, the simplest version of a 4-sided polygon is called quadrilateral. As you would assume, the word quad means 4. So 4-sided polygon is called a quadrilateral. Now, the thing with four-sided polygons is they have various types. So even though their general term is quadrilateral, we have certain few number of quadrilaterals which have different properties. So for example, we can have inside of a quadrilateral, it can be a parallelogram, which essentially means that the opposite sides are parallel to each other. So these two sides are parallel. Then we can also have the most commonly used ones, a square, which has all sides equals, and a rectangle. So these are different types of four-sided polygons. These are all quadrilaterals, but since they have all varying properties, they are all given their own respective names as well. Okay. Four-sided, 4 interior angles and 4 straight sides, so that's perfect. So another one is a trapezoid, that's correct. Exactly 1 pair of parallel sides. Okay. So over here, actually, that is correct. So this would actually be a trapezoid. Parallelogram is a special type of trapezoid, you can say. So let's rename this. Okay, so these two sides are parallel. In the parallelogram, all the sides are parallel. Okay. All right. So yeah, just to recap, a polygon is essentially a figure which is formed by connecting three or more straight lines. The simplest polygon is essentially a triangle, and then for four-sided polygons, they're all called quadrilaterals, and there are of various types such as trapezoids, squares, and rectangles. Okay, so this answer is correct. Let's get to the next question. So we were just discussing about trapezoids, and here we have a question where we need to find the area of the trapezoid. So if you would recall, a trapezoid has two parallel sides, and then the other two sides are at varying angles. We don't know the angles. So in this question, we're given a trapezoid. I'm just going to draw a symmetric trapezoid, whereas in reality, since we don't know the angles, it could be of any angle basically. So okay, now this side will have to be longer, and then okay, so that's our given trapezoid, and we know that the bases are 2 feet and 3 feet respectively, and the height is a quarter foot. Okay, so let's just mark those down. So the smaller base, which is at the top, is 2 feet. So this is equal to 2 feet. The bigger base is 3 feet, and then the height, which we can perpendicular, is equal to a quarter foot. Now, if you do not recall the area of a trapezoid, it is actually A is equals to half A plus B times H. In this case, A is the smaller base, B is the bigger base, and H is the height. What we can do is we can also calculate the area of this using just the regular shapes and their areas, which we are already aware of. So let's say you forgot the formula and you want to come up with a different way of calculating it. What you can do is you can look at this shape as a rectangle with two triangles on either side. So if we were to look at it as this, the area would be the sum of the areas of the two triangles. So area of triangle 1 plus area of triangle 2 plus the area of the rectangle. Okay. Once you do compute all of those values, you would actually come up with a formula which is exactly the same as this. Therefore, we'll just go ahead and use this formula to solve the question. But if you wanted to do it this way as well, you would come up with the right answer. So in our case, the area is actually equal to A is equal to 2 plus B equals to 3 times height, which is a quarter. So we would get 5 divided by A, which is equal to 0.625. Now, very important with these with this area questions is you always write the units at the end, 0.625, and then the units, since they are all feet, would be in feet squared. All right, let's just verify. In this case, they have drawn an asymmetric trapezoid, so essentially both of these angles are different, which is fine. The formula for the area does not change, and again, if you were to calculate the area of this trapezoid using this methodology which I mentioned to you, which is the sum of the areas of two triangles plus the area of the square or the rectangle, you would get the same answer. So looking at the solution, half a plus b times h. That's correct. Perfect. So this answer is correct. All right, let's get to the next question. Question number 8. What is translation in math? So some of you might be aware, translation, you can think of translation as translating from one language to the other, but math also has translation. So in math, translation means when you reposition or move a function by a certain distance. So what I mean by that is, let's say we're given a function, let's just do a simple function. Let's say we're given a function on our coordinate axis. Our function is y is equals to x. Okay, so you'll be familiar to draw this function. You would have a straight line passing through the origin, making a 45-degree angle with the x and the y axis. So our function would look something like, let's just include this. Okay, so this would be a function y is equals to x. And again, this is making a 45-degree angle. Okay, now if I were to add constant number or a scalar to either side, let's say I'm going to add it to the right hand side, x plus 5, what that does is it forces the function to reposition or to translate in this two-dimensional space. So this function would cause this to translate either in the upward or in the downward direction. So the easiest way to find out which direction would it translate to is to look at what value of x would make y to be equal to 0. So for y equal to 0, we would have x equals to negative 5. Okay, which essentially should tell you that this would have to actually move to the left hand side. That's correct. And similarly, for what value of y would x be equal to 0? So y would have to be equal to 5. Okay. So in this case, we actually move this function to the left hand side. So we essentially, what you can think of is we held it by its two ends and we translated it to the left hand side. So our resulting translated version of this would become, and then we will also have a little bit of the negative y-axis, negative x-axis, sorry. Okay, this is not helping, so draw. Okay, that's better. And then the function would essentially look something like this now. Okay, where this is equal to y is equals to x plus 5. This point where y is 0 is minus 5 comma 0, and then this point where this function intersects with the y-axis is 0 comma 5. Okay, and then that's this. This is the positive x, this is the positive y, and then this is the negative x. Now again, if you wanted to look at what the other function would look like, so that would still be somewhere here. It would still make a 45-degree angle. It's just that we have translated it to the left hand side to get to our new function. This has moved to the left hand side in order to give a certain function. So that's essentially what translation is. So you can think of translation as the moment or the as the motion of a given function to either it can move up, down, it can be scaled as well. So for example, if I was given the function y equal to x, and if I multiplied it by 2, then the function would scale. And if I multiplied it by half, then the function would also scale, but scale down in that case. So translation is essentially the motion of a function or a shape in a 2D or three-dimensional space by a given distance. So the distance, we can control the distance. Okay. So we're given this triangle according to this solution, and then we translate it by 90. So all of those points would move up by 90 to come to their final locations. And then essentially we can say that this shape has translated 90 degrees in the positive y direction. So this solution is correct. Okay. All right. Next up. Question number 9. Okay, just give this a second. Let's maybe refresh. Verify the solution again. Okay. Just give this a second, please. Sorry for the trouble. It should load on to the next question any second now. Okay. It's taking a bit longer than usual. All right, we're back up. It took a few seconds there. Let's get back to the next question. Okay, so the next question is, what is the square root of this given value? So for any under root or square root questions, we need to do the prime factorization of that number. So in this case, this number is 120. So we need to find under root 120. So the prime factors of 120 would be, so if I take out 2, I'm left with 60. Then if I take out 2 again, I'm left with 30. If I take out 2 again, I'm left with 15. Then 2 is no longer a factor of 15, so I'll try 3, which is, and then I'm left with 5. So basically, these numbers are the prime factors of 120. So therefore, 120 can be written as So 120 can be written as 120 is equal to 2 times 2 times 2 times 3 times 5. So square root of 120 is nothing but square root of the expression above, of this expression, 2 times 2 times 2 times 3 times 5. Inside this expression, we do see that we have 2 squared. So we can write this as 2 squared times 2 times 3 times 5. Now, this square root, we need to remember that if we have under root of a times b, this is nothing but under root of a multiplied by under root of b. Therefore, using that property, we can separate this 2 squared and essentially say this is equal to 2 squared times 2 times 3 times 5. 2 squared under root is nothing but 2, so we're left with 2 times, and then there's no further pairings here, so we'll have to use it as is. So this is equal to 30. So under root 120 is equal to 2 root 30. And then this would be considered the radical form, as it cannot be simplified any further. Okay. So we first get the prime factors, then we do the under root of each side, then we form pairs, and then we look at any pair sets we have, and then we can take them out. So this is perfect. So the solution is correct. Next up, question number 10. Can square root of 10 be simplified? So this is another square root questions, but this is a bit different. So for any square root questions, I know that the first step is from factors. So if I look at the number 10 and I try and get the prime factors, I'll start with 2, which is a factor. So I get 2 times 5, and then 5 doesn't have any further factors. So the prime factorization of 10 is 2 and 5. So therefore 10 can be written as 2 times 5. Oops. 5, and then square root of 10 is nothing but square root of 2 times 5. Now to simplify any square root, we need to find pairs and then use those pairs and take them out of the square root to further simplify. In this case, we don't have any pairs. Therefore, what we can say is under root 10 cannot be simplified any further. This is the simplest form. This is the radical form of this. So under root 10 cannot be further simplified. Okay. So 2 and 5, which are not perfect square, therefore this is the simplest form. So the solution is correct. Okay, next up, question number 11. What is a double line graph? Okay, so I'm gonna give an example for this. A double line graph is essentially a plot where you're plotting two, let's say, examples or two sets of data with the same x and y axis. So, for example, if I have two people who are traveling a certain distance, and on this x-axis we have the units of time, and then on the y-axis we have the units of distance. So let's say if I have a rabbit and a tortoise, which is a pretty general story which everyone's aware of. So for the rabbit R and the tortoise T, they would have a certain plot. So the distance traveled by the rabbit and the tortoise per unit time will be different. And then if I use these and I plot them against the same plot, we will get a double line graph. So essentially, what this would look like is, since the rabbit is much faster, he would be covering more distance in less time. And then conversely, since the tortoise is slower, he will be covering less distance in the equal amount of time. Okay, so this plot above would be the plot of the rabbit, and this would be the tortoise. Okay, so what we have done in this case is we have taken two different, you can say, examples and plotted them against two variables on the same plot. And this is called a double line graph, is when you plot two separate identities on one plot with the same variables. Two related data sets that are being compared, which is exactly what we are doing. So in this case, we have distance and time for runner 1 and 2, and you have seen those plots, so that's correct. Again, as they have explained here, the interpretation would be is that the rabbit covers more distance d in the same amount of time as the tortoise covered. Uh, However, as you know how the story goes, the tortoise ends up winning in the end. So essentially, what that would look like is after a certain distance d, uh, the rabbit falls asleep, and then this plot is somewhat straight. And then as time increases, the tortoise catches up. So this would increase. So that way, the tortoise will win. So the solution is correct. Right, on to the next question. Question 12. How do you write 66% as a fraction? So anytime you're given a fraction and you need, or a percent, and you need to convert it into fractions, the first thing you need to do is you need to divide it by 100 and get rid of the percent sign. So 66% can be written as 66 divided by 100. So as you said, you got rid of the percent sign and you divide the number by 100. So this is a fraction, but we can simplify this further because we know that 66 is divisible by 2 and so is 100. So if I divide this by 2, I get 33, and then if I divide this by 2, I get 50. So therefore, 66% is equals to 33 over 50, which is the simplest fraction which we can get to. So delete the symbol and divide by 100, that's correct. And then you can divide both sides by 2 and you get the final answer. So the solution is correct in this case. Okay, next up, question number 13. How do you write the area of a formula for a circle as pi r square? So essentially what this question is asking us to do is prove that the area of a circle is indeed pi r square. So what we're going to do is, let's draw a circle first. Okay. We're going to use another property of the circle which we know to get to the area of the circle. Okay, so we're going to assume that, okay, we don't know the formula for the area, but we do know the formula for the circumference. So the circumference is the distance you would travel around the edge of the circle is equals to 2 pi r, where r is the radius. So from the center, if you draw a line, this is the radius r. So we're going to assume that we are aware of this as being the radius, and then we need to find the area of this. So the simplest way of doing this question is actually to divide this circle in a bunch of segments and then look at it as a rectangle. So this is the same circle as drawn above. What I'm going to do is I'm going to think of this as a bunch of segments. I'm just going to draw 4, so it's actually maybe a bit more than 4. So if I think of this circle as a bunch of segments, okay, what I can do is I can take out each segment and arrange them in a rectangular form. So what I did here is I am going to take this and say that this segment would look something like this. And then I take the next one here and I put it but upside down. So this would come in like this, and I do that for all of them. Okay. So in the end, we would get a shape of this sort. And what we can do is, what we can look at this shape as is a rectangle almost. So if the more segments you will get, as the segments approach to infinity, this shape would look more and more like a rectangle. In our case, we only used about 7 or 8 segments, so it doesn't look like a rectangle, but the further along you go, the more like a rectangle it would look. And then in that rectangle, we know that this distance is nothing but the radius. Okay, since we took it out, and then that distance is the radius. And then what we also know is that this distance here plus this distance here is the total circumference. So now if each of those added together give us the circumference, we know that one of them would be equal to pi r and the other one would be equal to pi r. So the sum of them is actually 2 pi r. Therefore, from the formula for the area of a rectangle, area is actually equal to pi r times r, which is equals to pi r squared. So we started with the circle, we cut it into several segments. And essentially, you have to cut it into infinite segments in order to get a perfect rectangle. But for the sake of simplicity, we only cut it into 6, 7, or 8. And then you use the formula of a rectangle, the area of that, to calculate the area of the circle in our case. So this is indeed the formula of the circle. Say again. Okay, radius is d over 2. So we get the formula for pi, and then we know circumference is equals to 2 pi r. Okay. So this is actually incorrect. The circumference would be, this should be equal to just pi r, and this should be equal to r. The length of the top side should be just pi times r, and the right hand side is equal to r. This is because the circumference is split in 2 halves when dividing in segments. Okay. All right. So I think we've reached the end of the stream here. If you did enjoy the stream and if you do have any further questions, please check the description below. Please feel free to like, comment with any of your questions, or and subscribe to the YouTube channel. We do post these streams very frequently and cover various subjects as well. This was Nehel The Tutor, and thank you so much for your time. I hope you have a great day. Thank you. Bye.